Hello, everyone. Thank you for that great introduction, and APB has indeed been very, very stable, so that's what I will be talking about today. I am the VP of Product Engineering at Xaxis. I work in the demand group, so most of the products that I work on are meant to figure out how to optimize campaigns easier, cheaper, and more efficiently. For anyone that was in London, there was an announcement of 2 new exciting services. One was the programmable bidder, which I'll be talking about the most today. But the other one was streaming log-level data, which is real-time access to your event log, which I think anyone who works with log-level data now has been looking forward to. How do I get my data faster and cooler? Throughout the entire summer, I think any engineers that were there were thinking about how do I mash up these 2 technologies together and what crazy things could I build? And we've started down the path of building at least one of those. Introducing CoPilot. So CoPilot is a product that we've been working on. It is in pre-alpha, alpha, and it's intended to be your in-flight assistant when you're running campaigns. I've been in ad tech for several years, and I have so much respect for people that run and optimize campaigns manually. Their day jobs are not glamorous, and they're usually kind of numbers geniuses. They do a lot of work downloading spreadsheets, crunching through data, making decisions, and working in the console to optimize campaigns. Our goal with CoPilot is not to replace these people. It is to augment the sort of tedious work that they've already been doing with more automatic AI, I hope, and allow them to do more strategic, higher level thinking about the campaigns that they're running. So instead of cutting the lowest performing domains from a spreadsheet every morning, why don't you think about pockets of inventory and segments that might be more beneficial for your campaign? You can think of CoPilot as a set of pipes connecting our decision engine to AppNexus. I like to say I'm not a data scientist, I am a data plumber. So my job is to figure out where's the data and how do I move it to where it needs to go. And then I let other very smart people work on the algorithms that sit in the middle there. The product that we've actually built takes in, right now, the batch log level data into a Hadoop cluster. And we have a little prototype off to the side that is looking at the streaming log level data. This runs through a modeling engine powered by Uzi. I'll talk a little bit more about the stack later. It converts it into a decision tree, and then from there it was a pretty easy translation into the Bonsai tree language. So that was pretty much our entire summer project, and I'll tell you a little bit about what was good and what was bad about that. First of all, some challenges that we had from a business perspective. Xaxis is an international organization, over 40 countries, and in every single country, people set up their campaigns completely differently. Things that you would think are obvious to us who've been running campaigns in America are completely different to people running campaigns in Europe, completely different in APAC. So trying to build a product that was generic and flexible enough to meet all of those different needs was one of our first challenges. The other is the actual business cases. So are we doing CPA campaigns, viewable CPM, is performance business, how are we selling these products? So I can't stand here and tell you that we solved every one of those problems, but we tried to design a system that was flexible enough so that we could in the future. One of the most interesting challenges that I had, that coming from classical software development, I'm used to having QA people on my team, and I found that when you're testing campaign performance products, you actually have to spend money. So it's not like you can just have someone click a button and see what happens. You actually have to have someone spend some cash on the network and then see if it performs or not. I found that's a completely different skill set. So normal functional QA testers have a very hard time figuring out why your campaign is not working in the network versus taking someone who's familiar with ad tech and knows how to optimize campaigns manually. They can see it in an instant. It's like instinctual, why is this thing not working? And the last piece that we haven't really solved yet, but we're talking about, and I would love if anyone has any ideas, is how do we describe this narrative to our clients? So a lot of what we do when we're running campaigns for people is tell them the story of what we saw in the data, what patterns we discovered, what decisions we made, and why we shifted their budget into different directions. When you let a robot start doing that, it makes really weird decisions. Like it might decide that 2 a.m. on a Saturday in Finland for below the fold content is where it wants to spend all of your money. And I don't know how you describe that to a client, you know? It's not a normal story. So what we're doing right now is saying, I don't know, the robots did it and robots are smarter than us, but I don't think that's going to fly for very long. So something that we're working on is trying to identify in the data what those predictors were and see if we can generate a narrative from it. Technical challenges. This is something most of you have probably experienced in the past. When we kicked off this project, we created a new Scrum team, so the engineers hadn't worked together before. We plucked a couple of people from around the organization, a few consultants, and a new engineering team always takes a while to get its legs. Go guys, they're in the audience today. We inherited a code base. So the first version of CoPilot was built with similar data science methodologies, but it was intended to push different campaign objects through the console API. So for a single line item, we would be generating 30 different campaigns, and each one would have a different bid price and different targeting profiles. So we had to take the code that already existed and figure out how to shift it into a single campaign bonsai tree type of model. And the last challenge we have that may or may not be unique to us is that we have many, many different seats on AppNexus. So that means when you're downloading log-level data, figuring out campaign strategies, and pushing things to the API, you have to make sure you do that all on the same seat. So you can't really mix your data too much. A little bit about our stacks. This is the technical stack. I would not be an engineer if I didn't include this slide. I had to do it. I'm happy to talk in more detail afterwards if anyone has any questions. But the main idea is that we use a lot of Apache services in what we do. Hadoop is used for all of the modeling and processing steps. Java is the language of choice, and we have recently started using the Weka science library in order to generate those models. Storm is our queue processor, so every time we identify a new bonsai tree change, it goes into the Storm queue, that picks it up and pushes it to AppNexus console. And then, of course, we've got some modern JavaScript frameworks and some memory databases, stuff like that. The data stack is actually a more interesting picture to me. So the orange boxes here are actually data that is sourced from the AppNexus platform. The blue boxes are unique or proprietary to us. So from Salesforce, we get metadata about the media plans and the campaigns, what KPIs are the clients looking for. Zeus is our own internal analytics system, and it has some attribution and conversion funnel data in it. Turbine is our flagship product at Xaxis. It is our proprietary internal DMP, where we have, pretty strong audience profiles about everyone we've ever seen in the network. Taking those starting pieces, we mash it up with what we've seen in performance in the AppNexus event logs, and of course, whatever's configured on the campaign object. So what type of goal is it? What is the goal value? What is the budget that's set? Those things in the console. All of those together become the enriched data set that our robots look at. The goals and the budgets are then taken into account to decide what to bid. I actually wanted to include on here what the algorithm was for deciding on a bid price, but I decided that was our secret sauce, and then Brian included a slide with the entire algorithm in it, so thank you for that. But in case you're wondering, it's basically the goal value times the probability times some random number. I'm not going to tell you what my random number is. This is our team stack, and if you haven't noticed, I like referring to things as stacks. This is our Scrum team. The orange boxes have yet to be filled. You can see a very bright quality assurance orange box there, but I have had volunteers from the company helping me out with testing as much as possible. One thing I'd like to mention on here, I think everyone that's been doing agile development is used to the idea of combining product owners and QA as part of a core team all working on one product. But I think data science has always been treated as a sort of external service, maybe like a different guy over there who you ask a question and he gives you advice. We started our approach that way, but we didn't have a ton of success. And something that I learned is that your data scientists need to be a part of your core team. And especially in this data-driven world, there's no reason to treat them like some external resource. Our data scientist goes to stand up on our team every morning, writes in Java, contributes code. I've found that blending them together, the data scientists tend to get a little bit more engineering sensibility, think more in terms of how do I productionalize my discoveries, and the engineers get better at data science. So everybody kind of gets better together. All right, a little bit about our experience as we built. In our first attempt, we basically took that 30 campaign object that we had already built, that strategy, and tried to shove it into the bonsai tree paradigm, which was very challenging. That algorithm was based on clustering, so we were looking for groups of performance indicators that seemed to go together and then attached some bid prices to those. I think we limited it to something like 20 or 30 clusters, and instead of pushing campaign objects, we made really long if statements that joined all of those values together into an absolutely crazy tree, which I will show you in a moment. These types of trees that we experimented with early performed okay. They were a tiny sliver above what a manual trader would perform as, which is good for the most part, but it wasn't quite the performance that we were looking for. It was also very, very difficult to translate into the bonsai tree syntax. It just wasn't a natural progression from clustering to bonsai. This first approach, everything was hard-coded. So I think this is actually a good example of what it's like to do agile development. You don't need to download a bunch of libraries and come up with a wild architecture in your first approach. Just sort of get it out there and start testing and see what happens. And I think what you learn from that first prototype will influence the decisions that you make for your later versions. Here's what our first clustering bonsai looked like. And I summarized it so it would fit on a slide, but really a single if statement would span 100 lines in your text editor. I don't think the engineers at AppNexus ever thought we were going to build trees that looked like this, and so this was where most of the testing happened. When you start combining every single keyword together, you blend the any's and the every's, you blend strings and integers. This was some pretty good QA testing. And eventually it came down to the point where we had a conversation with the AppNexus engineers, and they said, listen, this is not what bonsai trees are supposed to do. It's like, okay, maybe we'll change our approach a little bit. Then came our second attempt. A bonsai tree is built to be a decision tree, so we decided to go back to our modeling step and just make decision trees, hopefully thinking that it would be an easier translation, and it turned out that it was. The data scientists picked the Weka library. I think it's pronounced Weka. It might be Weka. But either way, we basically took the data, cut out the clustering, built a tree, and we had to put in some limitations about how deep the tree went and how many branches we could make. Because our first attempts, the bonsai trees came out much larger than the 2 megabyte limit. So that was basically it. From there, it was a fairly natural translation into the bonsai tree syntax. I can't tell you too much detail about the trees. I'll tell you what I know if you'd like to ask me afterwards. But I do know that right now we've stuck to a binary branching strategy, which I said yesterday, very excited that I know the term, and then I saw there is something on the schedule for today. Everything we know about binary branching is wrong, so don't hold me to that one. Here's an example of what our decision trees look like now. Again, I had to manually pare it down. These are very long 4,000 line trees that come out of the machine. But you can see it just looks better. It feels better. And I've been a coder for long enough. I know when code smells bad, and that first version just smelled really bad. This version, when you look at it, is much more elegant. You can kind of understand what's going on in there. And it's, I think, a good place for us to grow. I am nervous that now I kind of have to rebuild everything for the 2.0 version, but that will be a fun process. Here's what we've seen in terms of performance on these new trees. And I love this graph because it speaks to a great success and a new emerging problem. The CPA costs is this orange line for a CoPilot-driven campaign versus a manual campaign are outstanding. It costs us a lot less to get conversions using this strategy. The shaded area is how many impressions we served. which is crazy. So CoPilot is casting a very wide net, serving tons and tons of impressions and getting very cheap conversions out of it. A manual trader casts a very small, targeted net and gets more expensive conversions. Based on what we told the machine to do, it did an excellent job. The trouble is we sell most of our clients on a CPM basis. So this is a very, very expensive solution for them. We've been discussing what to do about it. We can either re-educate the clients, which is never a fun conversation to have, or we can continue tuning our algorithms to see if we can get the performance that clients expect to see. So some lessons learned. Many, but I could only include a few in this presentation. The first one is that being an alpha customer with AppNexus has been an absolute pleasure, a ton of fun, and a really cool learning experience. I feel at times like we really are an extension of the core engineering team. We have a Slack channel where we can just dump thoughts and ideas, and they are very kind when it turns out to be a user error, and very responsive when it turns out to be a system error. So I am looking forward to alpha testing on the 2.0 version. I was talking to Alon earlier about the streaming log level data stuff, so I really hope that Xaxis and our engineering team can continue to test and play with these products early and innovate on top of them. That said, alpha testing any new product can be extremely frustrating. And I don't think that it was more so with the AppNexus product. I just think if you want to sign on to do alpha customer work, you have to expect that you have an alpha product. As long as you're comfortable with rolling with the punches, I think that you can do a good job. Publisher IDs weren't working. We decided comment it out and move right along, and the product still worked anyways. We were able to uncomment it about a week later. Breaking changes. Again, thank you for the breaking changes that I saw on the deck right before this one. I missed this announcement when it came out. It was kind of my fault because I said bonsai trees should take integers as their values. AppNexus agreed and then made everything take integers, which meant my campaign object pushing and my logs, everything changed. So I think they gave us 60 days notice. We made these changes on day 70 or something. So that was tough. Data scientists and engineers should be on the same team. I mentioned this. I can't emphasize it enough. I think it's a great new paradigm for agile development moving forward. Everyone on the team needs to understand the pain of manual optimization. These people live and breathe by their spreadsheets. And as soon as your engineers understand that, they'll know why you're pushing them so hard to make these crazy bonsai trees that are not human readable. Well, it's like neither is 17 million spreadsheets. So the spreadsheet problem will never go away. They'll still have those. It's just hopefully they're looking at higher numbers. Also, campaign optimizers make the best cross-platform QA testers. I already mentioned earlier the importance of who's doing the testing. I just want to say it's easier to train someone who knows ad tech well in how to do basic QA testing than it is to train a QA tester on how to do ad tech. That is a life of learning, and you're going to have an easier time if you go the other direction. My last little insight, which has been actually it was an early debate with one of the engineers here, but we worked it out, is that a bonsai tree is not the same as a targeting profile. In our first attempt, we did not have a targeting profile when we ran a bonsai tree, and we targeted by just returning 0 for stuff we didn't care about. That was weird because we weren't shaping the traffic that was making it to the bonsai tree at all. The point of a tree is to set the value, not to decide if you're going to see the impression or not. Later on, we decided to map the targeting profile one-to-one to the bonsai tree, and then we weren't getting enough impressions at all because we were too restrictive. So I think what I've come to is I'm going to need separate algorithms for how I value it versus do I want to see it, especially if I want CoPilot to control some of those early prospecting steps. And it sounds like now I'll need a model for what creative should I show. And I think that's actually a cool world where you just have a garden of models everywhere. And you know, my last lesson is just don't be afraid to jump in and try something new. I feel like AppNexus as an organization has demonstrated this repeatedly, being the first to offer a programmable bidder type of feature. an algorithmic marketplace, I would like Xaxis and our engineering team to take a lesson from them and never be afraid to innovate or be the first to market with something that seems insane but turns out to be really fun and performs better than you expected. That's it. Any questions? No questions. I brought a whole team who I told me to ask questions if nobody had a question. So.
I have a question.
Yes.
I was just wondering, how dynamic a process was it for you to like replant your bonsai trees?
That's
once
cute.
A day,
I
once
like
a week, once an hour.
I like the gardening analogy. So the product that we have live right now is doing once every 24 hours. The production version of the product is crunching through the batch log level data and builds a new model. We do have some prototype experiments going on where we're looking at the streaming log level data, and my dream would be to have an incrementally updating model that is pushed live every time a change comes. Apparently that's bleeding edge data science, and I'm asking too much. The real answer is we don't know yet what the difference would be in performance if we were updating the models more often. I did put one tree live and let it run for 3 weeks without ever touching it again, and it was crushing manual performance where they were tuning the campaign every single day. So I think I would need to do more research into the value I would get out of a more frequent update, and I'm not yet convinced it needs to be that frequent.
Right here. Hi. Did you get around the 2 megabyte limit by penalizing for complexity or breaking the tree into multiple line items?
I suppose penalizing for complexity. We didn't want to break into multiple line items. But I don't know if this is something everyone has experienced when trying to do the Bonsai language conversion, but we ended up getting a lot of blank branches out of the original model. So the approach that we took was to prune everything that didn't really make sense. It might have meant sense in the data science, but it didn't make sense in a bonsai tree. We actually haven't hit the 2 megabyte limit yet. I think we hit around 1.5 megs pre base 64 encoding, and you don't get judged on the base 64 encoding. And I've actually heard you only get judged on size once it gets converted into that Lisp model format, which is even smaller. So I think I have a ways to go before I hit the 2 megabyte limit. If I do, I'll come up with a creative solution for it of some sort.
Okay. Back middle? Sticking to the gardening analogy, how much water does it take to figure out if a bonsai tree will grow or not? How much water did you have to spend?
Oh, how much money to spend? That's actually a good question. So I was nervous about that whole spending money thing in the beginning, right? So every line item, I tested every tree that I planted. I spent only, $50 a day, and then I got really risky and I spent $100 a day. And then my campaign managers are like, "I just got you a $30,000 budget. We're going to drop $5,000 today." I was like, "No!" But I think the lesson I learned is if you perform at a $100 a day budget, like, good for you, but you need to know if you can perform on a real budget, and sometimes the model won't give you the same spreads at a bigger spend than at a smaller spend. So I don't know what other people should do, but I jumped into the water very slowly, little tiny budgets until I knew that things were working at least reasonably well, increased the budgets and saw good results out of it. Moving forward, when I'm doing development on a new algorithm, I'm not sure yet how I'm going to fund that, but I have heard rumors of features where you could test traffic as if it had run through your tree. So that's something I'm going to be looking at right away. Without spending the money, basically. Simulating that you'd run it without having run it.